All right, go.
Hey everyone, my name is Josh Miner, and behind the camera is Sean Kermani.
Yo, what's
and
up?
We're here to show you our 445L embedded systems final project. So what we did is we created a face tracking camera that we configured here. So here's our PCB. We have a TM4C microcontroller. The microcontroller has a bunch of pins running out onto our logic analyzer pins. And these run out to, if you go to the camera over here, we have an ArduCam 2 megapixel camera, and then we have a gimbal consisting of two servos that we're controlling with PWM signals. So part of this project was writing the driver for the camera, and this camera uses an SPI bus for sensor or for control. So if I want to say to start taking a photo, I send an SPI command. That's just part of the documentation for it. That's pretty simple to configure. And then it's also I2C to configure like the brightness, the size of the JPEG you want, and if you want JPEG at all for things like that. So that's one aspect of the project. And now we have over here Particle Photon, which is an Arduino-based Wi-Fi board. And so we're communicating from the TM4C to the Arduino Wi-Fi board using an SPI bus. And the Arduino Particle Photon is the master in that transaction sequence, and so the TM4C has an edge-triggered interrupt to signal to the Arduino Wi-Fi board that it wants to begin sending photo data over. And so now we'll give you a quick demonstration of what this project does. So as you can see on the top of the box here, we have two red LEDs and two green LEDs. And so the idea is that we snap a photo, we populate a photo buffer on the TM4C, we ship that over SPI to the Arduino Wi-Fi board. It sends that to a server and then runs the image through a convolutional neural network to determine if there's a face in it. And if there is, then we'll just update our state on the TM4C to show that there was a face by green light, and we'll also output some servo commands to center it on your face. So Sean here has the camera in front of his face, and as you can see, we're heavily bounded by the network latency, but once the response does come back, it does center on your face pretty effectively. And then if he leaves the frame, for instance, so he goes out of the shot, then the last photo received was a face, but now our new response will come back and these LEDs will become red right when the next response comes back. And as you can see there's no face in the shot anymore, and they became red. And so in order to control the camera remotely, we created a simple like flask application running on an Apache server. So go over here to the laptop, we have the site running on, and we're just simply updating updating the site with the last image received on our server. So if John can just stay there, then I'll come back into the shot here, and I'll go a little off center from the image, and then it'll try to center on my face. So that's just a quick example of what's going on. And then because our network latency was so high for this project, we decided we might as well implement a time-lapse mode for the camera. So that if you just click on this button here, then the camera automatically is configured to do a time-lapse mode where it'll readjust the servos and begin slowly panning across the room, all the while storing photos in a buffer on our server. So then if you want to reset the image it's taking, you can start a brand new time-lapse. But for the sake of brevity, we'll show you what we already captured just recently. And so as you can see, the camera is slowly moving to our left and just going across the room. So that was a cool feature. And then the final feature of this project was the control panel. And so from our laptop, so if I was sitting in the PCL, for instance, the library here on campus, I could just move the camera around using these my arrow keys on my computer. So the last image received was this lamp. So if I want to go see what's over to the right of the camera, I press the right arrow key, And now the camera is configured so that when it receives the next response, or when the TM4C receives the next response, it's going to start panning to the right. Once again, we're definitely bounded by our network, but now you can see it's slowly going to start moving over to the right. And if I want to start moving down, I press the down key, because obviously it's pointing a little bit too high right now, so if I want to see what's going on a little bit lower, then it starts moving down. And that's our final project. Thank you.